Hello everybody, welcome to EPG Pathshala. We all are learning geography, and in geography we are learning remote sensing and GIS. The lecture for today is cloud-based GIS. I am Dr. Seema Mehra Parihar, who has been teaching remote sensing and GIS now for last 30 years. I have had share of my learning from Indian Institute of Remote Sensing, Dehradun. My PhD is on Natural Resource Management from Department of Geography, Delhi School of Economics, University of Delhi. I have also had an experience of ITC Netherlands, where I was a postdoc fellow. In this lecture, you will learn the following. You will learn about the cloud computing, you will learn about the cloud-based GIS, you will understand the essentials of cloud GIS, you will also learn about the key steps to move to cloud GIS, and you will be able to comprehend advantages and disadvantages of cloud-based GIS. Of course, if you look at the timeline of GIS, and you also remember, because you have already studied so many lectures, you will also find that around in 1850s or something, where you had paper maps, and then 1960s in the quantitative revolution, when the GIS was introduced, and to today it is something which is so very different. And that is the reason why today we are talking about the cloud-based GIS. 2000 onwards, this is in. And do you know something? The cloud computing in India is growing from a $50 million industry in 2009 to a $15 billion industry in 2013, and much more than this in 2017. It is growing, and this is the platform where in future all GIS based applications are expected to happen. So that means 2000 onwards, slowly all those people, the ones who are using GIS, are shifting to cloud-based GIS. But still, what we find that also only the larger applications of macro level are the ones where this is being used. But with the scope and the sharing power of cloud-based GIS, this can definitely be branded as future of GIS. This is because everything these days seems to be moving towards cloud. If you recollect your definition of GIS from the introductory chapters of GIS, you know it is CSTART, where S is storing spatial and non-spatial data. And today GIS is all heading towards cloud, because cloud is gaining momentum in storing contacts, calendars, documents, articles, images, accounts, presentation, and you name it, it's there. Consequently, what is happening is that many private GIS based companies and foremost vendors are developing today cloud based geospatial solutions, cloud based. So the market is expanding, and therefore to understand the key aspects of cloud GIS is very important, especially if we are learning today in 2017. And in this lesson, what we are going to talk about is going to talk about the concept, economics, feasibility, and advantages and disadvantages of GIS. First and foremost, it's important to understand for us is what is cloud GIS. And before embarking on this cloud-based emerging set of technologies, concepts, and work practices, it is important to understand it is not a kind of settled set of services, but require new critical thinking for making decisions. At the same time, what appears to be relevant today in cloud computing, including cloud GIS, is a decision towards adding cloud computing in your organization, process management, research methodology. You have to change your orientation. Cloud computing refers to hosted services on the internet for storage and access of your data and programs. Instead of your computer hard drive or local storage device, the technology makes the use of internet, central remote servers, and a virtual infrastructure to manage your data, applications, and computing needs. Cloud offers instant access and computing of any volume of workload, on demand, form and location, any device. There are various working models for easy access and operation, namely say surveys and deployment models. So that means Cloud GIS is different than your desktop mainframe GIS. This is definitely convenient, on demand, network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Is it clear? Yes. Access to a shared pool of configurable computing resources. Access to a shared pool of configurable computing resources. That's so very important to understand. So let us ask following key questions vis-a-vis this Cloud GIS. Say in case if you know it, how is everybody able to locate your home location on a Google map? Is every location specific? Ask yourself, is cloud-based platform borderless? Think. Is it secure? Imagine. If it's in somebody else's custody, how is it secure? Let's see. Foremost, what is important to understand in the cloud computing is the concept. Whose cloud it is? What is cloud computing? Cloud computing is a concept and a phrase that has become today so popular that number of competing definitions have also come. The best definition of a cloud computing, which is accepted by everybody, came from National Institute of Standard and Technology, NIST, which consists of following things: 1. Essential characteristics, 3. Service models, and 4. Deployment models. And this definition was given by National Institute of Standard and Technology in 2011. That means 6 years back from now. Let's look at the definition. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing services or the resources, example network, servers, storage, services, so on, that can be rapidly provisioned and released with minimal management effort or services and provider interaction. This cloud model promotes availability and is composed of 5 essential characteristics: on-demand self-service, broad network access, resource pooling, rapid elasticity, measured services, and 3 service models: SaaS, that is cloud software as a service, cloud platform as a service, PaaS, and a cloud infrastructure as a service called IaaS. And 4 deployment models: private cloud, community cloud, public cloud, and hybrid cloud. And the key enabling technologies include fast wide area networks, powerful inexpensive server computers, and higher performance virtualization for commodity hardware. Is it clear? So that's something what is Cloud GIS. So we have learned new words. We will again get into little detail of them. Cloud GIS refers to, that means hosted services on the internet meant for users of GIS technology or members of public who want to access map services, including map service, data storage, and access powerful analysis with applications to manage assets and information. So another thing which I want you all to learn is, what is cloud status? Cloud status refers to the real-time view of the performance and uptime of cloud products and services visible on dashboard showing status, updates of cloud performance, and so on. So now let's learn another word called community cloud. What is this community cloud? Community is one word, cloud is another word. community cloud is a cloud deployment multi-tenant model. That means there are multiple clients which are hosted on that cloud as a community. That means cloud is a shared infrastructure managed and secured by the participating organization with a common or shared goal. So, community cloud is a cloud deployment multi-tenant model. Is it clear? So, then we also have a private cloud. Private cloud is a cloud deployment model where the cloud infrastructure is accessible by a single organization for greater data control and security. So, all those the ones who are so much worried about the security can have a private cloud, but can shift to a cloud GIS. You have not to carry your hardware with you, is it clear? Every time you carry your hard disk or your computer or your laptop and so on and so forth. It is accessible from anywhere. So, after private cloud and community cloud, what is the cloud? The third cloud starting with P? Yes, public cloud. Public cloud is a cloud deployment model made available over a public network to multiple clients with shared infrastructure and pooled physical resources. Is it clear? And then we have another cloud starting with H. What is it? HYBRIT, hybrid cloud. Hybrid cloud is a cloud computing environment in which an organization combines the security of private clouds while running applications from the public cloud. That means the public and private cloud infrastructure operate in tandem using an encrypted connection for communication. A hybrid cloud environment can also be a combination of two or more clouds, say private, public or community, connected by proprietary technology, not necessarily open source. So, is it clear? Yes. So, now we know 4 clouds: private, public, community and hybrid. So, what is spatial cloud computing or the GIS based cloud computing or a cloud GIS? Cloud computing with geography is definitely added and will benefit, because more than 90% of the geographic data which has taking place today has geography component, has locational component. So, data hosted on a cloud is very important, and there are 3 cloud service models. If you remember that definition, you will be knowing it. One is SaaS, SaaS. This is called cloud software as a service, where the cloud software is used as a service. Then we have PaaS, PaaS, where cloud platform is used as a service, cloud platform as a service. Then you have IaaS, cloud infrastructure as a service. So, fine, just revise this. What is SaaS? Correct, cloud software as a service. PaaS, cloud platform as a service. IaaS, cloud infrastructure as a service. So, these are 3 cloud service based models. We all remember CSTRAT from our lesson 1, capture, stores, transform, retrieve, analyze and display data. Let us now remember for cloud GIS another term, ANSEF. What is this? ANSEF, where cloud GIS accessibility, it's borderless, accessible from anywhere. N is network accessibility from anywhere. D is on demand based service. S is sharing, resource pooling, we are sharing. Elasticity, flexibility is there. Fixed service, whatever the service that you ask for, you will pay only for that. And H is external house hosting. Hosting is externally done. So, what is it? ANSEF. Let us now go one by one towards that. A is accessibility, it is borderless. Cloud GIS is borderless at a basic level. It is accessible to anybody and everybody who wishes to use cloud computing for different GIS based applications. For example, with data placed in the cloud, one can visualize world map, map of India, use seamless number of spatial analysis, perform advanced level network analysis, and so on and so forth on a data that is hosted on cloud. Coming to N of AND, network access. Cloud computing services can be accessed from a variety of network devices. Guest network devices, yes, you're right, workstations, mobile phones and other servers. A GIS example is a geospatial information service that allows access from browsers and from other servers. Let's now talk about D of AND, demand-based service. Cloud computing services should be accessible at will without having to consult and get permission from. I want it just now and I'll get it. And a GIS example is the ability to start multiple map servers by using a browser interface. S is sharing. Simply, that means we can share. Resource pooling is there. Cloud computing resources such as processing power, storage and input-output to use the different architecture are provisioned for different clients from a common set of physical assets. Clients need not know and exactly where the physical assets are. And the GIS example is sharing computers owned and administered by, say, different places. Then coming to the next alphabet, that's called E, and that's elasticity. Cloud computing services can be scaled up and down to meet demand and decrease waste. And that's something called a flexibility you have. That means something you need, something you don't need, you can throw it out. A GIS example is processing a large spatial data set quickly using many cloud computers, which are then discarded when it's not required. You have converted that particular task to a knowledge and then now say, all right, goodbye to that data. And F stands for fixed and selective services. Cloud computing services are paid for by resources used, such as that means like, whatever you're using, you're paying only for that. You don't need everything in infrastructure, such as processing, power, storage capacity, number of user accounts and so on. GIS example is like, say for example, you're paying for a map server only for the hours that it's being up and the bandwidth it uses, rather than a whole computer. Isn't it very nice? And for this, of course, this information which I just gave you, I have to be thankful to Ferriola D, because he is the one who has put it in such nice words. Now, in case if we take it forward, we realize that the market recognizes that the cloud-based services are going to be the future and are important. And today you have following. You've got Map2Net, you've got ArcGIS Online, you've got GIS Cloud, you've got Mapbox, you've got a Mango Map, you've got a CartoDB and Map Infostrators and so on and so forth. That means they are becoming important. You also have to start using it. EC2 is a cloud computing services from Amazon that allows renting of virtual computers and run your own computer application. It also provides an environment for running the ArcGIS server. I'm sure there are many more on the market or about to hit the market, and so that means there's so many. You only have to be at lookout of it. But the point is, if it is available, it's accessible, I only have to pay for something so small, then why it is more difficult to move towards a cloud-based GIS by GIS organization than the others? And here, what enters is the concept of hybrid cloud also. For an organization with less than say 50 terabytes of data to manage, it's easy to move everything there. 50 terabytes, but we all know that it's much more than that. 50 terabytes is something which is so less for the GIS organization. For the organization, the geospatial industry with GIS system consuming and processing petabytes of data, this is challenging and unrealistic. The business value of public cloud infrastructure is desirable, but where there are such large volumes of data, it's hard to get there. Obviously, we can understand. Lift and shift strategies which are there to mimic on-site infrastructure in the cloud are not often viable when petabytes of data are involved, and many businesses need to keep at least some data on the premises. I hope you all will agree to this. We talk about the petabyte of data. Luckily, the utilization of the public and the private infrastructure does not have to be an either or decision. maybe, maybe not. It doesn't work like that. But in case if there's so much of the data to be managed, that means, public cloud, hybrid cloud is something a big decision. We have to eliminate a lot of data boxes that's globally accessible, and we have to pay as you grow. Pricing models are also all possible on premises behind your firewall. Hybrid cloud approach is not simply having some apps running in your data center and other apps running in Amazon and Google. It doesn't work like that. Workflows do not have to be wholly reside within either private or public infrastructure. A single workflow can take advantage of both, and that is the catch. True hybrid cloud is when public and private resources can be utilized whenever it's best for the application or process. Here are 4 key steps to accelerate your journey to the cloud. Step 1, go cloud native. Step 2, go according to policy. Step 3, go cloud to cloud, and step 4, go deep. Step 1, where we go cloud native. Storage and its large size is the primary inhibitor preventing movement towards the public cloud and a cloud architecture in general. We all recognize different data sets. They are all strongly structured, stuck in separate repositories, and locked down by specific access methods required by specific applications. This makes it impossible, or at least extremely expensive, to effectively manage, protect, share, or analyze data. Then we also have newer cloud native applications. Use unique interfaces, whereas classic applications use older prototypes to access data. While converting everything to cloud native format will save much time, money, and headache in the long run. This does not have to be a massive project. You can start small and progress over time to phase out large generation. That means you can start with small also. So that means, and this journey to cloud by leveraging cloud native storage on premise is just very doable. And once you are cloud native, not only is your data ready to take advantage of public cloud resources, but you also immediately start seeing the benefits in your own environment, and that's something which is so very important. Of course, you've got a lot of policies and all that, and we have to work towards a policy or all those principles which are there. And besides that, on-premises data which can be easily replicated to the public cloud in a format of the applications and users can work with. But remember, yes, we need to remember, we're talking about hundreds of terabytes or more with each data set having different value and usability. Data management policies in the form of rules help decide where data should be placed based on the application. That means we need to be very strict in noting what we want in a workflow, and that has to be computed. For example, you may be working with large applications, and you also need at the same time a lot of on-demand processing resources also is required. Say there's a disaster and you need to take a quick decision, and many people are helping around. All those assets also have to be mapped. You also need cluster nodes, and which are there in multiple geographic regions to protect and location optimized data. Cloud becomes helpful. You will go to cloud, but don't worry, the cloud data management software views the entire infrastructure as a single pool, which is universally accessible regardless of the backing storage hardware or location. Right, that's step 2. You have to remember your guidelines. Step 3 is go cloud to cloud. Policies help automate and orchestrate services to your applications based on business requirement. For example, cost, capacity, performance, so on and so forth. And of course, at the same time, according to different capabilities of your on-premise or cloud resources. This also means data is efficiently discoverable and accessible across multiple clouds. The cloud management platform considers the difference in the services provided by different clouds and moves to copies data the right one. So that's something which is so very important. And of course, with a particular web service also, this data has to be synced, whichever web service. So once you are clear about the guidelines, you've decided you'll go from cloud to cloud. Now what is that? Now move inside, go deep inside. When the data placement policies enable a true hybrid cloud workflow, not constrained by physical infrastructure, you can definitely come across and you can unlock more capabilities. What is a data on data called? Metadata. Yes. So that's an organizing principle. Cloud native data holds its own metadata right alongside it, not a separate database, only its own specific application. Can read. Your metadata can now be globally indexed and made available to many applications and groups of users. This also allows you to perform large scale intelligence projects. That means it's also very important. So in case if it's an intelligence based commercial enterprise, metadata is also correctly placed. That means you can expand on the user base. And slowly the transitions of your organization moving towards the cloud-based GIS can also be followed by you. Fine. So now we are clear what is GIS, what are the essentials and all that. Let's now talk about the advantages and disadvantages of these two, as given by Dean Howell. First and foremost, which can be taken as an advantage and disadvantage, is data access. Access can be via any internet connections, anytime, anywhere. I see this as both advantage and disadvantage. If you have a good internet connection, then it's great. But with a bad internet connection, of course, you will get frustrated if nothing else. So that's something which is there. Another advantage which is there, if you have a range of remote users, then Cloud GIS makes the distribution of your data analysis and system very simple. No need to send data using DVD or down anywhere. You can just put it and you can use it as you're using your now email account anywhere. Another advantage is which is there is of data capturing. Of course, it becomes easy. Having a Cloud GIS, it allows data to be captured in real or near real time to be displayed directly onto your system. Say for example, you're using a real-time GPS and you're doing that survey, you can easily get it in access anywhere. There are also many successful applications of where data has been captured by the general public and verified by the users. One such success story is of course the OpenStreetMaps which you're seeing. Then at the same time, e-commerce also becomes possible through this. The ability to sell your data or online services to a wider audience can open up the income stream for your organization through a Cloud GIS. I hope you all would agree to this. Then the IT management of course is possible. The need to have a dedicated GIS administrators will be reduced as you can outsource that to the Cloud GIS hosting organization. When you have so many advantages, of course, just shift to that. But at the same time, there are certain disadvantages. One is a security concern. Security, of course, if you remember, is an important aspect of any system, and you will need to make sure good security in place so that your data is not accessed by users who should not be accessing. Of course, it's something of a concern. And software companies, services companies are working towards it. And the data volume. GIS data has always been big and taking about the gigabytes on your own server. If you move to a cloud solution, then there is both the time to migrate the data to the host server and also for end users to access and download. Then there is a lot of, we've got a clever sampling software out there for where the web-based GIS so that end user may not notice any issue. And downloading is another thing. And of course, the major disadvantage or major concern for somebody, the one who's got security concern also, is the issue of external hosting. This can be a major concern. As a Cloud GIS hosting organization may not have your best interest at heart. There is always a fear. Then of course there are business after all in it make a profit, but they will also be striving to provide you with a valuable service so that they do not want things to go wrong. And what sort of backup and redundancy systems are in place with your cloud host is again another issue. So we also have to see that nobody else is backing up, the data. Today we know that whatever, when we're working with a global delivery model. So you're working, somebody else may also be working, or somebody at some other place, it may be some other time. Then another thing which you should all definitely note, well, is the Cloud GIS host offering you a dedicated server or not? If not, then who else is sharing that? And what sort of load is their system but for? So lack of control is another downside of the Cloud GIS. That means control is in the hand of somebody else. That means you do not know that the way your data is used, displayed, manipulated, analyzed and so on. So to add a new function or layer may not be as simple as just loading a new data set onto the server. Another disadvantage is the data format. What format is the Cloud GIS application serving the data out? Do you need to reformat your data is another concern. So now we see that there are advantages and disadvantages. But certainly, Cloud GIS is here to stay. You have to look for a service that meets your needs, your data formats, your end users, and the level of the control you want, right? And for this, of course, what will enter your mind is the cost. Let's now go one by one to this cost business. Do I save anything? Let's compare traditional GIS, open source Cloud GIS, and another managed Cloud GIS. So we are doing traditional GIS versus open source GIS versus managed Cloud GIS. So this license cost is yes for the traditional GIS, but no for open source Cloud GIS and managed GIS. That means open source is better than that. Next, let's see the hardware cost. Hardware cost, if we look by it, again in the same, we find yes for the traditional cost, paid directly to the cloud provider in the open source Cloud GIS, and monthly fees is there in the managed Cloud GIS. So let's talk about the software customization cost. Yes, it's there in the traditional. Yes, for the open source, it's inclusive in the monthly fees. If we go by the data cost, yes for the traditional GIS, yes for the open source GIS, but it's included in the monthly fees in the managed Cloud GIS. If we go by the maintenance cost, it is yearly for the traditional GIS, it's yearly for the open source GIS, Cloud GIS, but for the managed Cloud GIS, it's included in the monthly fees. So what do we conclude? We know that whether you like it or not, now what you have seen, yeah, you got slightly nervous, I know, when you thought about the external hosting, security and so that. But for me, what is important is that GIS cloud base is here to stay, and you will be in the cloud in some capacity, whether for functional need, budgetary alignment, or due to top-down pressure. All companies will benefit by executing part of their workflow in the public cloud at some level. Of course, it's hassle-free, and you have to make monthly payment, so keep aside in a budget. But to bring many of the business dynamics of cloud pricing based on consumption, massive scalability, collaboration, and so on and so forth is so important. I hope you learned so much. And of course, it's much more complicated. In a short span of a lecture, I could not have done with you. We need to still learn more about the cloud computing, about the cloud architecture, open source and cloud computing. We need to work on the future of cloud computing and so on. But dear friends, I enjoyed teaching you Cloud GIS, and I wish that you also all would have learned from it. So be ready, gear your organizations, gear your close ones to Cloud GIS. Thank you very much. Thank you.